Hello, I am Seung and welcome to 2021 Dev Day. And I am the presenter for Pipe. And I am from Line Plus Productivity Engineering team. And what I want to present is the Pipe solution that our team developed. And Pipe is a sort of an ecosystem that has CI/CD and runtime. Using Pipe, we want to enhance the productivity of developers, and we also want to improve the experience of developers. So let me explain more in detail. Here is the agenda for today's presentation. First, I want to explain about Pipe and what efforts we are doing to improve the service level, and lastly, the roadmap that we have in plan. First, about Pipe. Pipe currently has two components, Pipe Workflow and Pipe Runtime. Pipe Workflow is a combination of Tekton pipeline and GitHub events. We chose Tekton, and the most important factor we considered were first, can it fully automate CI/CD? And second, was making declarative pipeline definition possible. So when we were reviewing the solution, we reviewed many solutions other than Tekton as well, such as Argo CD. But we thought that Tekton would be the right choice for us when we thought about operating and patching. So we aim to provide fast and reproducible build and test using Tekton. So Tekton is based on build and test, so it needs runtime. So that's why we provide managed Kubernetes platform. This is not only to run the test, but to host containerized workload by users as well. So using Pipe Runtime, we wanted to design a solution that minimizes external dependencies and in-house dialects. So we wanted to make it easier for the developers to use this solution. So let me explain more in detail. Then why did we develop Pipe? Let me explain about the background. Internally, we do have many CI/CD solutions. You probably are familiar with Jenkins and Circle CI, Drone, Argo CD, and other solutions are currently used in our company. But you may wonder why we made another solution. We had some problems that we wanted to solve, but these solutions were not integrated and these solutions were not opened. So we wanted to provide a pipe stack so that developers didn't need to understand and learn about our stacks, but among the components that we provide, we wanted the developers to only selectively take what they wanted to use. And secondly, when users are using Pipe Runtime, we do have in-house Kubernetes solution, but this in-house Kubernetes solution is not Kubernetes native. So it doesn't have kube control, and it is mapped with OpenStack. Of course, there are some merits coming from that. It means that you can freely use open source resources. But we thought that de facto CLI, meaning kube control or de facto Kubernetes ID, should be able to be used natively in the environment, and that's why we wanted to provide to the developers. And second is container runtime. So we provide namespace as a service model. So it means that we don't give dedicated Kubernetes to developers. They can apply It goes through the workflow. It doesn't go through any approval, but you just come into our website and you can just create by using the button. By using namespace as a service model, we wanted to have minimal resource to be wasted because we needed boilerplate nodes to run Kubernetes, and we wanted to minimize the load on the nodes so that developers can have admin in their namespace and they can optimize the usage and quickly use the service. And another merit is that if we have n number of Kubernetes by projects, it has an upgrade issue of clusters. It's difficult to upgrade regularly. But for us, we only have a few selected container runtimes, so we can have less cost for management. By minimizing management cost, developers can use up-to-date evergreen status Kubernetes. So we provide namespace administrator roles to users, and we don't use RBAC feature on Kubernetes, but we use Kyverno policy engine to manage that. Let me explain about the pipe workflow then. Pipe workflow consists of Tekton and GitHub events. Tekton is native CI/CD framework, and we provide Tekton pipeline and CLI catalog and many more services. Tekton is a part of CD Foundation, and it doesn't have any dependency on Jenkins. Other available solutions usually use Jenkins natively, or they have to call Jenkins to use. But for Tekton, it doesn't have dependency, so it can provide the service faster and in a more flexible way. Secondly, GitHub event. In CI/CD stack, we cannot take GitHub events because all the developments are mostly based on GitHub. So in order to handle GitHub events, we set annotation field. So the model that we made takes the syntax from GitHub actions. For GitHub action, developers probably have a lot of experience, and in order to handle GitHub, in order to handle it, we thought that it would be better to use GitHub action than us just developing something. So we have GitHub actions syntax provided on top of Tekton pipeline. So whenever there's an event, developers just need to define on Tekton's annotation field. This is the workflow. The user is the developer, and it has an action to GitHub, for instance, push or release. Whenever there's a change, the pipe app itself works with webhook, and this webhook is run with GitHub. So GitHub's user, if they have pipe installed, GitHub sends the event using webhook. Then we read the event and we list the Tekton pipelines from the repository after we search. So we do templating and we create pipeline run instance. It's class and it has a role of an instance. So based on pipeline, we add pipelines and then we create pipeline run, and the parameters, meaning what event is in and what kind of tags and who created this event. These kind of information can be contained. So we inject that into runtime, and the result of the templating is run on our runtime, and the result is shown as commit status on the user side. So this is the result of the pipe workflow. When pipe workflow runs, you can actually see the stacks. For instance, what kind of steps failed and succeeded, and it's updated in real time. So developers don't have to see pipe website. You can go on to GitHub and you can check how your work is being done. Of course, we do provide runtime as well, so you can also come into runtime and you can check it for yourself. This is the workflow log. The workflow that we provide is Tekton pipeline, so it's using, you can also use TK and CNL, but it can be inconvenient. So we also do have a feature that you can check it on the website. This is something that we developed recently. This is called Workflow Scaffolder. The purpose of this scaffolder is that Tekton's pipeline, in the initial phase, when you first create it, it can be a little bit heavy. The file's a little bit long, so the boilerplate codes are long, and it's kind of burdensome to code one by one. So we provide this scaffolder feature so that developers can select what namespace to run prod, or whenever there's an event, what kind of Slack channel that they will receive information will be put in. And secondly, for instance, Golang or Gradle or Nodes, the platforms developers want to run can be selected, and you can select the version, and you can just click on Scaffold button, and Tekton pipeline is created, and you can just download it. Using this feature, developers can easily use Tekton pipeline, I guess. This feature was inspired by Circle CD because there was a similar feature on Circle CI. And also Jenkins Blue Ocean also has a similar feature. After a series of efforts, we wanted to improve developer experience, and we put a lot of thought into this. And we provide reusable tasks on pipeline. On Tekton pipeline or Tekton tasks, there is a Tekton hub, and it's a repository for managing. And there are hundreds of pipelines in Tekton hub. And among that, I think the most commonly ones that the developers will be used, and for Git clone, you have to use it to Git Enterprise. So there are some reusable tasks that we as liners need. So you only see a partial list, but building container image is a main one. So our service is run on container runtime, so building the container image is necessary, but task for building container image is like Conical and Build Kit, and there are many features. So we just wanted to integrate so that developers can use cache to quickly build. And for build Gradle as well, Line has Nexus repository, and you can just publish to Nexus repository. In other words, from upstream Tekton hub, you can add some internal features, and we provide a curated service. Second is Scaffolder. So Scaffolder supports pipe users to adopt CI/CD best practices easily. So that was the purpose. So not just using Tekton pipeline and using the template, but we wanted to think about the best way to actually deploy. In Scaffolder, there's only 3 examples, but we have about 5 supported. ci.yaml, build.yaml, and cd.yaml. ci.yaml is on GitHub push or pull request to non-default branch, and the second one is on GitHub push or pull request to default branch, and cd.yaml on GitHub deployment. So let me show you some samples for each. First, ci.yaml. It's for non-default branch, and whenever there's a pull request, it's run. So what we do is that we run lint and unit test. Of course, there's also integration test as well that can be run. In this case, whenever there is a change in the external repository, it's run with the pull request. The syntax is on the right. You can see tecton.dev v1 beta 1. And annotation is pipe.line.com event. And below that annotation, you can see GitHub Actions syntax in a usable format. So you can just put in this syntax and it just works the same as GitHub. So it has branch ignore. So if it's not the main branch, CI pipeline is run. Secondly, if there's a change on default branch, you need to do lint and unit test, and you also need to create deployment, and you also have to deploy to stage. So it's different than the first one. So it's not branches ignore, but it's just branches. So it means that there is a change in the main branch and it does the 4 tasks. So we thought that main branch, meaning if there is a change on default branch from build to deployment, we have the up-to-date source codes to run. And we thought that it would be easy to debug. So that's why we provide this as the default setting. And last one, if a new tag is created or if deployment is created, this is, so you have to create a new tag and you have to push a tag. So in this case, it says push text event as a trigger, and we have the CD pipeline that's run with this syntax, and this deploys to production. So here are the 3 models that we thought are the best practices that we wanted to provide. Now, pipe runtime. I guess you're probably more interested in runtime if you're a non-liner. So let me talk about pipe runtime. So we use Kubernetes as namespace as a service model. And pipe runtime consists of core cluster and runtime cluster. So we have 2 models. In core cluster, pipe API and website are being hosted. So all the events that's coming in from GitHub are going to that pipe API. And also OIDC authentication is handled in the core cluster. And the second one is runtime cluster, and this gets the build requests and it provides the environment for user workloads. So runtime cluster is deployed per region, and we have Tokyo and Osaka, Singapore as regions, and we deployed to those regions. And runtime clusters handles authentication using core cluster. And deployed, there can be a big cluster. For instance, it can have Kubeflow. For the cluster that has over 1,000 nodes, it can be very hard to manage because it has a lot of nodes. So we are thinking about providing a separate cluster for that. And this is the base for the Kubernetes. And our Kubernetes runs on physical machines. The reason is that in the past, in other services, we used physical and virtual machines together. And for nodes that run on VM, it caused a lot of outage or went to non-ready status frequently. So in pipe service, we didn't want to have any dependency on virtual machines. So we wanted to go with 100% physical machines. We provide kubeadmin, and for kubeadmin, we didn't use kubespray. For kubespray, it's a universal tool, so it's not customized. It doesn't have customized features for a line. For instance, we have Ansible script that we developed in-house, and we use that to provision. But if we use kubespray, it's actually really slow if we use it. So that's why we use in-house Ansible script to provision. And I will explain a little bit more in the latter part. And currently, the versions that we use is 1.21.1. Our service has only recently been opened, and we just wanted to go with the version that we tested a lot. And we are planning to have an upgrade in the version. But you know that Kubernetes version 1.2, many of the APIs have been deprecated. So for 1.21, it was okay with the old APIs, but after this version, there are a lot of errors because a lot of APIs went deprecated. So we are thinking about how to deal with that. And we always have to think about network interface and runtime interface and storage interface. Here are three. And we chose Calico with Typha IPAM plugin for CNI and Containered for CRI. And storage, there's no problem because we can just add or delete. So for storage, we use OpenEBS, and we have Verda shared file system that we use internally. The reason why we used Calico with Typha IPAM plugin is that one of the requirement was that it has to be scalable. For kubeflow, big nodes and GPU nodes are used. So from 1,000 to even 2,000 nodes are needed, and network interface became a problem. And second was a scheduler. If we use big or if we use machine learning like kubeflow, we thought that network load would be much bigger than scheduler. So that's why we had to consider that when we were selecting a plugin, and we came across with Calico. It's de facto. We use Calico for testing Kubernetes, so we applied Typha plugin to Calico, and the performance was actually good, so we provide our service with this. Typha plugin is kind of a proxy node in between Calico and Kubernetes. So each IP doesn't bring from Kubernetes, but it goes through Typha plugin. So kube API's load is lowered. So Typha can serve up to 200 Calico nodes. So theoretically, it can serve up to Kubernetes nodes for 4,000. We don't have a big requirement like that, but so we didn't actually test it with that size. But when we tested in the past, when we ran with 1,000 nodes, there was no issue. And nodes have roles, and it has control plane, build, gateway, and none. So here are 4 types of node roles. Each workload is scheduled based on the role of the nodes. So these are the installed components. Service mesh in Istio and Ingress Contour is the default, and we also have Ingress Nginx as well. So you can also choose Nginx. For load balancer, we have Verda load balancer that's mapped, and for build, we use Tecton and build kitd. For observability, we have Fluent, Bit, and Prometheus, and for authentication, we have Dex, and we use policy. We use Kubernetes for policy, and for storage, we have these 2. This is the authentication flow. Using Dex, runtime goes to OIDC end, and core cluster has to be already running. So there should be a core cluster, and when the Dex is running, runtime kube APS server discovers the OIDC endpoint, and then after that, user requests resource like Kubernetes get pod, and the runtime validates ID token, and it goes through auth2 flow. And when you go to second Dex, there's ID token, and with that ID token, when you go to runtime in the last phase, since this ID token is valid, it handles the user request. We issue 16-hour token, so if the developer actually tries to use it, it can be used for a day. And this is the authorization flow, and we use RBAC and Kubernetes. So we use RBAC permission to do basic permission check, and if we need more, we also use Kubernetes policy. The reason why we chose Kubernetes was that Kubernetes was a little bit easier to use than open policy. So developers can go to our dashboard and they can download kube config file, or they can create namespace or call pipe API. So it can also get API key, or you can download GitHub app. So you can do a lot of features like that. So how did we try to improve the service level? First, monitoring. We use the basic monitoring tools, Grafana, Prometheus, and we do have Alert Manager, Kube State Metrics, Node Exporter, and Prometheus, and we also have Metric Server and Node Problem Defector. For alerting, in Kube State Metrics, we check whether the node is ready or not, and we check whether a client certificate will be expired next week or not. So we do have the events in our Slack channel. So if we get the alerts in our Slack channel, we know that there needs to be some operation done. And if the pod is not healthy, or if the pod is crash looping, or if the endpoint address is not ready, so we do monitoring of these states. And we have maintenance work, 2, which are backup and pipeline. So we back up HDD for every 30 minutes. We don't do it internally, but we use do backup on Verda object storage, and it's similar to S3 on Amazon. And in runtime, we clean up the user pipeline runs older than 7 days to prevent etcd overload. So that's why we try to keep it clean. And we have pipe control plane. Other than pipe repository, we do have pipe control plane repository as well. What control plane aims to do is that its provisioning or reducing. I mean, there is a lot of maintenance work, and we wanted to use ring zero concept. So the first model was that it was kind of similar to Ranch. We had a cluster over the cluster. So the top cluster managed lower level cluster. So we thought about that, but we tried, and the problem from the top cluster was spread to the cluster in the bottom. For instance, if the load balancer was broken or the certificate was expired, we could not run the low-level cluster. So we changed the structure. Pipe control plane is used on Jenkins, and pipe itself uses Jenkins on VM for CI/CD and provisioning, and it's to reduce circular dependency. And Kubernetes cluster is managed by Ansible playbook that we made. And lastly, Kubernetes components are managed by Kubernetes technology, for instance, Helm file and Customize. Node roles now. We separated the node roles because we wanted to do scheduling differently for different workloads, because build takes up a lot of CPU and memory. But if it takes a lot of CPU and memory, workload that the developer was already running is being affected. So builder node and workload node should be separated. And we use Kubernetes and we used mutation webhook to separate them. Last, I want to explain about the roadmap. The weak point that we have is high availability. We only have one cluster, not multiple clusters. So if our cluster is broken, many developers will be damaged. So in the future, we plan to support multiple availability zone in line. So if this happens, there will be pipeline and worker nodes can also use, and we can distribute them in multiple availability zone, and worker nodes as well. We can distribute so that even if one IDC goes down, other services can be continued on. Secondly, this is something that we are developing. It's called as functions, and we are developing it right now. It's similar to AWS Lambda. The purpose why we want to provide functions is that we do have the basic infrastructure. So we wanted to actually provide a better platform. So we wanted the developers to use cloud native events and boot workloads easily. If you use functions, developers currently do need deep knowledge on Kubernetes infrastructure, but we aim to provide this function so that developers can just use it without deep knowledge. So it's similar to Heroku, Netlify, or Google App Engine. And we already had function service in Verda, and we want to replace Verda function with these functions, and we wanted to provide more events, and we wanted to support more language, because Python is only supported in current one, but we want to provide more languages with improved DX developer experience. And this is something that we are surveying right now. It's called CPaas, Control Plane as a Service. So we have separated namespace and we have separated cluster, and it's something in between. If developers set virtual cluster, in underlay, it's only shown as deployment, but underneath, it's like a full scale cluster. So it's like Minikube. So if we provide a cluster like this, maybe developers can do custom resource definition, or you can easily develop using this vCluster. Other than that, if you use virtual cluster, it's more scalable. But we are just surveying it right now. And if we have better understanding and better experience, maybe we can provide this. Last, VM-based CRI. This AW Firecracker or COT containers are the default that we were thinking about. Using these solutions, we thought that we can provide a more secure runtime environment. So we have a plan to support this feature as well. So this is it for my presentation. Thank you so much for listening.